So today we are solving this problem. Find the original typed string 2. So let's read the question first. So Alice is attempting to type a specific string on her computer. However, she tends to be clumsy and may press a key too long, resulting in a character being typed multiple times. Like usually we also do this mistake, right? Let's say if I'm typing hello, then we might type, if we keep on pressing this O, then this might go, some extra characters might be printed, right? Otherwise HELLO, that should be fine. But if we by mistake, if we keep on pressing O, the extra characters would be occurred here. So this is what does it mean. So C has this kind of habit. C might press it and some extra character would be resulted. So you are given a string word which represents the final output displayed on Alice's screen. Like in my screen, this is hello, right? So you are also given a positive integer k. So one integer k is also given to us. So return the total number of possible original strings that Alice might have intended to type. If she was trying to type a string of size at least k. Since the answer may be very large, so return the modulo 10 to the power 9 plus 7. So let's understand with one example first of all. Suppose this is our string A, B, B, C, right? Now we have to find that as per given in the question, total number of possible original strings that Alice might have intended to type of size at least k, right? So from here we can guess that if a character occurred only one time, right, that means it was definitely intended, because even there was no case of long key press, right? That is why it is only single character. So for single occurrence we can definitely say this was definitely the intended. But when it comes to that there would be a multiple occurrence of a same character, then there's a chances that this might be or might not be of a mistake. For example, if C was only typing A, but C kept on pressing A button, then these extra A also might occur. Or C want to basically typed A, but due to mistake this extra A occurred. Or C might be intended to type A only. So we just cannot say, because this is a multiple frequency. So this may be or may not be an intention. Similarly for B as well. But for C we can definitely say that C typed C only and C didn't make any mistake. Now there could be the multiple possibility for it. Suppose we can see like this, that how many types of possibilities could be there. So you can observe here that there could be these many of possibilities. Okay, for example, you can observe here that this is the entire string itself is the intentional one, because C might be typing this only B, C. So this could be the one possibility, that C has the intention to type this string itself. Or C might be typing these 2A by mistake because of the long pressing, and rest of all are the intention. So C might be resulting this guy. So if we remove these A, this also might be, these red one are the by mistake one. So this also might be an string A, B, B, C. Similarly, there could be like only one of the A is because of that, right? Maybe there's the possibility that only this A was the extra typed, okay, because of the long pressing. So this also could be a possibility. Similarly, this B also might be, this B, the red one might be because of the mistake, this might be typed. Similarly, the last A might be coming as the because of mistake, and this B at the same time. Or maybe these 2A are coming as the mistake and this B also, right? So now we can say that these would be the intentional stuff. These are the possibilities, right? So how many strings we have found? We have found 1, 2, 3, 4, 5, 6. 6 strings are the one which are coming from the intention of Alice. Okay. So now you would have observed one thing, that we have found the frequencies. If we look at the frequencies, A repeated 3 times, right? B repeated 2 times, and C repeated only 1 times. If we multiply all of them, 3 into 2 into 1, if we multiply their frequency, we will get the total combination. So total combination becoming 6 here, and these are the 6 strings only that we have found. Now suppose our k is equal to 4, right? Because in the question it is said that a k is given to us and the string intention should be greater than or equal to this k, right? You are given you are also given a positive integer k, so at least size k should be there. So if we look into this, if k equal to 4, who all are the valid for Alice? So this string is valid because it is having greater than or equal to 4. This also valid. This string also valid. This is also valid. This is also valid. Only this one is not valid because it has the length 3 only. So what would be total? 5 would be the answer for us here, right? So this is what we have to do. We have to look for the k as well. Okay. Now the next thing is how to do that. Also, one more thing we can observe here, that if our groups, right, we have found here 3 groups, right? One group is having 3 frequency of the A, another group having 2 frequency of the B, and the third group having only 1 frequency of group character C, right? So we found 3 different character, but our k was 4 here. But suppose we had like one more group. Let's say we had D also. Let's say we had like this D and D also. Then we would have another group of size 2, right? Now in this case, if we look that at least one character definitely we have to pick from every group, because by mistake only the repetition is happening, but intentionally she wants to type at least one character, right? Even when she is making mistake, at least one of those characters we have to pick, right? So if we have the k group, I mean k equal to, or like here 4, k equal to 4, and here group also 4 or 5 or whatever, if it is more than k, in that case whatever is the total coming with the multiplication of their frequency, that should be our direct answer, because all these strings that I have generated would be definitely of greater than or equal to k size, because we have to pick from every group at least one character. So in that case we can directly say that if the number of groups are greater than or equal to k, we can directly return the multiplication of these frequency as our answer, because there would be no string in the combination which would be having lesser than k length. Okay, so this is one check. Now we have to look for other scenarios here. Here our step 1 should be to find the groups and their corresponding frequency. So how we will do it? We can definitely create an array list. For example, let's say we have an array list, then we can easily find that what would be the groups and what would be their frequency, right? So if we use a for loop, we can start from here that okay, A, this is also A. Then what would be the total frequency of it is 3, right? So we found one group. Then we have another group B, right? So it has frequency 2. Then we have third group which is C, so it has only 1. So now once we found the frequency, so here you can see that what would be the size of this array list. So array list size is 3 here. So this 3 would be there would be 3 groups. Okay, so groups would be here 3, right? And their frequency is sitting at these indexes. So we found total 3 groups. Now we will check here. As soon as in step 1 we found the frequency and the number of groups, in step 2 what we have to do, in step 2 we have to check whether is this group okay. So the group size, like whatever the size of this, if this group size of this basically the array list, if this is greater than or equal to k, then what to do? If this is greater than or equal to k, we have to multiply all those frequency. Okay, so using one for loop we can do the multiplication. So 3 into 2 into 1, 3 into 2 into 1, but only in the case when size is greater than or equal to k. So this would be our answer, direct check, because no string would be smaller than the k size. So this is our second check, that first we get the group frequency, then we have to check if it is greater than k, then do the multiplication of frequency. Now if it is not equal to k, then we have to look at how to make these string set, like we created this one. Okay, now one more intention is, why do we want to do this? Because we have to find all those who are having the size k. So we can do one thing here, that if we find total combination like we found with the multiplication of all these frequency. So if we found the total combination, that would be coming from the multiplication of those frequency. And if we deduct all those strings which are having the size less than k, okay, size less than k, if we find all those strings which has size less than k, so total minus size less than k would be equal to all those strings who had size greater than or equal to k. So this intention, we can this would be our intuition to solve this problem. Okay, so first of all we find the total, which we will find with the multiplication of those frequencies, minus all those strings which had size less than k. Now our next target is to find all the strings which are having the values less than k, right? Because we want all those invalid strings who has the length less than k, right? So what we will do for that? So we have already these words, right? And we created one array list like this. The array list for this was like this: 3 frequency for A, and 2 frequency for B, and 1 frequency for C. We have an array list like this. Let's consider this our array list which we created in step 1. Now we have to use this. So what we have to do is, we are creating one DP array. Okay, this is of size k. Why k? Because it is going from 0 till 3, which is our range, which should be fall under the less than k category. So we want to find that what would be the possible base to choosing 1 character, 0 character, 2 length string, 3 length string, like that. Okay, and at 0 I have started with 1. Why? Because 0 is kind of an empty string, and selecting an empty string, we can assume that we have one way. Okay, now we are traversing through this list, that list we just created in our step 1. What we are doing here is, we are with the count, we have the count of those characters, and for all of them. So what we will do is, first is A, right? So if we choose for A, okay, so for one character, how many ways we can there are 3 A's, right? So to choose one character, we can put it like this, right? And to choose 2 characters, we can put it like this, AA, right? And for 3, we can have AAA. All 3 are not going beyond the frequency of it, so we can do this for A, right? Now we are coming to, so you can see here, for 1 length we are making 1, for 2 length also we are making 1, for 3 length also we are making 1, right? Now we can look for the 2B. How these 2B's are coming there? So see here, length 1 is already filled by this guy, right? Length 2 is also filled by this guy, but here B also can accommodate, right? So here like AB also can be a possibility, right, other than AA. So one possibility we found here, we found 0 possibility here. Then how about here? Here also we can have like AAB and ABB, right? Because B came 2 times. Can we have 3B? No, we cannot have 3B because its frequency itself only up to 2. See here, right? Now we'll come to the 1C, right? So how does C would work here? This is already taken, so 0. This also 2 is already 2. We have found these 2 values, right? So this also would be 0. Can we found a way here? Yes, I think we can find one way here, is ABC, like this, A, B, and it can accommodate with the C. but it cannot have more than that, right? A, B, C, because at least in when she is typing, one of the character would be already there. Only because of mistake there might be the additional one. Okay, I'm saying might. Okay, so now for this we found 0 0 and 1 only. So in this way we have to update this DP. This DP would be the main DP, but to find the corresponding characters, like for A we calculated, for B also calculated, C also, we internally also would be used. So let me show you my corresponding for it code. So see here, first of all we are making the mod equal to 10 to the power 9 plus 7, because this could be a very huge number. Now this is our word and this is k. We are checking that if word itself is length 0, then there is no point we can return 0. Otherwise what we are doing, we are creating this array list. First of all, in first step, as we told here, we are creating this array list like 3 to 1. So what we are doing, initially we are making the count equal to 1, because we want to count the frequency of all the characters one by one. So see here, I am starting with I equal to 1, because we are checking for the previous guy if it is equal to the current one or not. So caret I equal to caret I minus 1, that means we are having a same frequency, so we are increasing it. Otherwise what we are doing, if that is not the case, then we are adding this count to the group, means group is in this array list, and resetting count equal to 1, just like here when we started here. From here we found that A is equal to previous A. Similarly here also we found A equal to previous A, so we made count equal to 3. But when we reach at this B, we found that B is not equal to previous character, this is A. So we added this count, whatever we found here, we added this to here in this list and resetted the count equal to 1 to count the B frequency. Okay, so same way we are doing here. Once we are done with that, we would be having this array list like this, the frequency for all the characters, right? And the size of this array is basically the total distinct characters in this words, right? See here, 3 is the size and we have 3 characters A, B, C, though their frequencies are different, right? So we are keep on adding. We have added those groups dot add into the count. Okay, we will keep on doing this, and finally we would be having the this groups sub array, which are having all these guys. Now what we will do, we are making initially this total equal to 1, right? And we know that if we are not bothering about the k size or whatever, we can have, like, if we multiply the frequency, we will find that many totals regardless of their size. So 3 into 2 into 1, we can get the 6 different strings. We in step 1 we already listed them down. Okay, so total we can find if we multiply all the frequency in the groups, right? So 3 into 2 into 6 in our case. So that would be the total. Now from this total, if we remove all those strings who has the length less than k, this will give us all those valid strings which has less string length greater than or equal to k. This is what we are finding. So see here, first of all we are checking that if group size itself is greater than or equal to k, at that time we would be directly returning total, because there would be no case of lesser length. Okay, otherwise we are creating a DP of length k, and initially we are putting DP 0 equal to 1, that way which I also put here. Now what we are doing, we are traversing through this group's frequency. Okay, group has the frequency and this group is array list, nothing but array list having all the frequency. We are traversing through it one by one, like from here if we start, it is 3 frequency for A. Okay, now what we are doing, in external at line number 27 we created this DP array, but for every character in the groups we are creating an internal DP array to check for their how many possibilities they could make. Okay, so initially this sum equal to we have put 0. Now what we are doing, we are traversing one by one till last, I equal to 0, I less than k, I plus plus. So see here, if I is greater than 0 means it is not 0, otherwise at 0 we have already filled 1. So if I is greater than 0, then what we are doing, sum equal to sum plus dp of I minus 1. Okay, that is why this I is greater than 0, otherwise it will show the exception. So when starting from 1, we are checking the sum equal to, it would initiated because dp at 0 is 1, we have initiated, so initially sum would come as 1, right? So in that way we are checking that sum equal to sum plus dp of I minus 1. Why? Because till dp of I minus 1 we would have already calculated the possibilities. Okay, now if our frequency, if I is going greater than frequency, like if let's say frequency is 3 and I is 5 when we are traversing, in that case what will happen, we cannot use any more the same characters, right? For example, here frequency of A is 3. Now let's say this array would having k equal to 7, so at I equal to 5 there is no possibility to use this character A, right? Because A is frequency having only 3, it cannot be used more than that. So for that reason what we are doing, we are making that if I is greater than frequency, sum equal to sum minus dp of I minus frequency minus 1. Okay, we are going to this step, and the mod are using here we are making plus mod because this might go negative, so we want to avoid that negative part. Okay, that is why we are making plus mod and then making this mod of that. Okay, now whatever sum value we got for still here, we are assigning this temp dpi equal to whatever sum we found. Okay, now remember this, that we are doing for every character one by one for every group. So we created this temp dp. Now whatever value we got for first character for I equal to 0, 1, 2, 3 up to k minus 1, we are directly assigning this temp dp to dp. Okay, because till that character we would have evaluated it. Now same set of dp we would have coming for the next group. Okay, so in that way finally when we will come out of this groups array, we would be having this dp having all the lengths starting from 0 till k minus 1 and the total possibilities. Okay, now we are making total invalid counts. So in this dp you can see here this dp is starting from 0, 1, 2, 3, 4, 5, whatever it is, correct? But we have to start it whatever the size of this this group. Okay, this array list, like this array list has 3. So in our case, because in the question it is given that only frequency could be because of the mistake, but at least one character would be definitely guaranteed occurred, right? A, B, C in this case. Okay, so A, B, C, whatever would be the size of group, that would be the basically the distinct count of these characters. Okay, so from there only we are starting. So you can see here we are checking all the invalid count when we had the groups dot size I equal to, in this case I equal to 3. Okay, because 3 is the minimum size for our strings. We just cannot skip any character completely because they might have multiple frequency, but at least once they are occurred. Okay, so we are starting I equal to group dot size and I less than k, I plus plus. We are taking invalid count with the mod. Okay, invalid count plus whatever is the dpi. Okay, in this range, not going from 0 but going from the groups dot size with the distinct size. Okay, so this invalid size we would be having here. Now what we are doing is whatever total we calculated here, from this total we will remove these invalid size. Okay, total minus invalid count plus mod and percent mod. Okay, this will give us the total valid counts strings which are greater than or equal to k. So let me execute this code. So I am running this code. Let me try to submit it, which I have already submitted, but again I am submitting it. Yeah, so it is accepted. So what is the time complexity here? So we are extracting, like let's say the length of word is n, and then we are exploring it k times, right? So n into k would be the time complexity, and at the same time we are taking the extra space as well, linear time complex, linear space complexity and quadratic time complexity, or you can say whatever n into k time complexity. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.